Let's take a simple array of 5 elements. A of 5 is, let's say, 10, 20, 30, 40, and 50. So as soon as you make this declaration, 20 bytes of memory is being allocated. So all these elements are integers, and the size of an integer is 4 bytes. 5 integers, 4 bytes, so that's 20 bytes in total. This is known as static memory allocation, which means you are declaring the array before compile time. There are several problems associated with static memory allocation. You can you cannot enter the size of the array during runtime. That's problem one. The second problem is you are not able to add new elements to the array. So add elements. Moreover, you are not able to delete any elements from the array. So three problems. The fourth problem is, let's say you have this code here, int main. Your array is declared here. Maybe your array was being used for the first 10 lines of the code, and so the array is used here, and for the remaining portion of the code the array is not used. But the problem here is this array, even though you're not using it for the remaining portion of the code, it's still going to be there in memory. It's going to consume resources, and that resources, which could have been used by something else, is being blocked. So we are not able to efficiently utilize memory. Now we might think that memory is very cheap. There's tons of memory, but in embedded systems which work very fast, memory is limited, which is why you want to delete things as and when you don't need them. So there are four problems here. Luckily in C, we can alleviate all the four problems using dynamic memory allocation. It's known as DMA. So using DMA techniques, you can ask the user to enter the size of the array during runtime. You can add more elements to the array. You can delete elements from the array. And you can also release the memory space once you think you no longer need the array. So we have the stdlib.h file, which provides four functions. The first function is malloc. The second function is calloc. The third function is realloc. And the fourth function is free. malloc and calloc are almost the same with just a few minor differences. Realloc, as you can see, it's reallocating memory. So you can either add more elements to the array or you can delete elements from the array. And free, as it suggests, we are going to release the memory contents. So those memory contents can be used by some other processes or some other arrays, if you're creating some new arrays then and there. So let's look into each one of these.